Find the y-intercept, if any, x-intercepts, if any, vertical asymptotes, if any, including the asymptotic behavior on each side, and holes, if any, for f of x equals 3x squared minus 3x minus 18 divided by 6x squared plus x cubed minus x to the fourth. The first thing to do is find the y-intercept, where the function crosses the y-axis, defined by x equals 0. The corresponding y-coordinate can be found by plugging that 0 in for x into the function, which will give 3 times 0 squared minus 3 times 0 minus 18 divided by 6 times 0 squared plus 0 cubed minus 0 to the fourth. 3 times 0 squared is 0, minus 3 times 0 is 0, minus 18, divided by 6 times 0 squared is 0, plus 0 cubed, which is 0, minus 0 to the fourth, which is 0. 0 minus 18 is a negative 18, divided by 0 plus 0 minus 0, which is a 0. This is not a limit, so that 0 in the denominator actually is a 0, and 0 in the denominator is not allowed. Therefore, there are none. The remaining parts are found by taking the function f of x, which is 3x squared minus 3x minus 18 divided by 6x squared plus x cubed minus x to the fourth, and fully factoring the numerator and denominator. The numerator has a common factor of 3, which will leave behind x squared minus x minus 6. The denominator has a common factor of x squared, but since the highest order term is negative, we may want to factor a negative out with it, so negative x squared, which means that the first term, 6, will become a negative 6. We'll write that last. The middle term will become a negative x, and then the third term will become the first term and become a positive x squared. All the signs will switch. So we'll have an x squared, we'll have a minus x, and a minus 6. The numerator is a trinomial quadratic, so it can factor into x and x, two numbers that multiply to be negative 6 and add to be negative 1, negative 3, and positive 2. We'll take care of that. In the denominator, also a trinomial quadratic will factor into x and x, two numbers that multiply to be negative 6 add to be a negative 1, which will be a negative 3 and a positive 2. We can now cancel out any like factors to give the fully factored canceled version of the function. The x-intercepts, where the function crosses the x-axis, defined by y equals 0, are found by taking the numerator in the fully factored canceled version of the function and setting it equal to 0 and solving for all x's. There are no x's to solve for, therefore there are none. The vertical asymptotes are found by taking the denominator in the fully factored canceled version, setting it equal to 0, solving for all x's, square root of both sides gives a 0. So we have the x equals 0 as the vertical asymptote. We do want to analyze the asymptotic behavior on each side by taking the left-sided limit indicated by the negative superscript on the 0 of the fully factored canceled version of the function, and the right-sided limit also of the fully factored cancel version of the function. Let's start with the left-sided limit. The left side of 0 is a negative number, but it'll be approaching to 0. So the factor in the denominator that's making 0 is the x, which will be a negative number, but it'll approach 0. So we can replace x with a negative 0. 0 can plug in for any remaining x's. There are no remaining x's. This will give a negative 3 over a negative squared is positive, 0 squared is 0. A negative over a positive is negative. Non-zero over 0 is an infinity. We can analyze the right-sided limit in a similar fashion, but it's the right side of 0, which are positive numbers, if plugged in for the factor in the denominator that is making 0, which is x. That will give a positive number, though it does approach to 0, so we can replace x with a positive 0. And then plug in 0 for any remaining x's, but there are no remaining x's, so negative 3 over positive 0 squared, which is negative 3 over positive squared is positive, 0 squared is 0. Negative over positive is negative, non-zero over 0 is an infinity. And the asymptotic behavior on each side match. They both go to negative infinity. The last thing are the holes. The holes occur for a situation when the function is factored, and those that cancel and fully cancel out the factors in the denominator. So x minus 3 canceled with an x minus 3 in the denominator, removing all x minus 3's from the denominator, so x minus 3 will be one of them, and x plus 2 did the same thing. It fully canceled out with all of the x plus 2's in the denominator. Each of those set equal to 0. We'll solve for the x-coordinate of each of the holes. The y-coordinate can be found for each of them by plugging the x-coordinate into the factored cancel version of the function. This will give negative 3 over 3 squared, which is negative 3 divided by 9, can reduce by a factor of 3, which will give a negative 1/3. So 3 is the x-coordinate, and negative 1/3 will be the corresponding y-coordinate. The negative 2 will have a y-coordinate found in a similar fashion by plugging a negative 2 into the fully factored and canceled version of the function. It gives negative 3 over a negative 2 squared, which is negative 3 divided by negative squared is positive, 2 squared is 4, and we have a negative 3 over 4, so it'll be negative 2. The x-coordinate, negative 3 over 4 for the y-coordinate. And there are the coordinates for the holes that will be found on the graph.